Okay, so related to the average rate of change is the idea called the difference quotient of a function. The difference quotient of a function is this thing. Remember when we did the average rate of change and we wanted to do the average rate of change between x plus h and x? It looked sort of weird and it wound up with an h on the bottom. Well, that thing that we did when we identified the average rate of change from x to x plus h was what we call a difference quotient, okay? And so this is based on the average rate of change. And so all we really want to do is we want to use this function f of x, 2x plus 91, in this formula, in this average rate of change formula. Only this time we're going to simplify the whole thing. So what we're going to do is we're going to take our f of x, 2x plus 91, and in place of x, we're going to put x plus h. And we did this before in a previous video. So we're going to do 2, and instead of x, we're going to put x plus h. Then plus 91. Then we're going to do minus, and then we're going to put in f of x, which is just 2x plus 91. And I'm going to put it in brackets, 2x plus 91. And then the whole thing is going to be over h. Okay? Now, the next thing we're going to do is we're going to distribute the 2 over the x plus h, and we're going to distribute this negative over 2x plus 91. And you're going to see something really neat is going to happen. So 2 times x is 2x, 2 times h is 2h, plus 91, minus 2x, minus 91, we're just distributing the negative, okay? And then this whole thing is over h. Well, watch this. Now we're going to combine like terms. We have 2x minus 2x. Well, that's going to become 0. So the 2x and the minus 2x, they cancel each other out. Then we're going to have plus 91 and minus 91. And they're going to cancel each other out. They become 0. And all we have left is this 2h over h. And what do you know? H divided by h is 1. So they cancel each other out. And all we have left is 2. So the answer to this whole thing is just 2. That's the answer, which is really interesting because this is a linear function. It's linear. And didn't we say that when we talked about the concept of the average rate of change, that the average rate of change here, the concept of the average rate of change, is the slope of a straight line. Well, what is the slope of this line? The slope is 2. This is mx plus b form. The slope of this line is 2, and that explains why the answer to this difference quotient is also 2. All right, now we're going to do an example with a rational function. We want to find the difference quotient for negative 6 over x plus 9. Here's our difference quotient format. And so we're going to go ahead and do what we did in the last example. So we're going to rewrite the function negative 6 over x plus 9, but we're going to put x plus h in for x. But before I do that, I want to show you something. Do you see this over h? We can actually make this whole thing a lot easier to deal with if we factor out a 1 over h. Let me show you what I mean by this. This is the same thing as 1 over h times f of x plus h minus f of x. Why am I doing this? Well, I'm doing it because we're about to deal with a fraction, and we don't want fractions in fractions. I don't want a fraction, 2 fractions, in the numerator of a fraction. So I'm going to take out 1 over h, okay? And so this is the same thing as this. If we were to put a 1 here and put that in parentheses, 1 over h, and this is, pretend that this is this over 1, this times this, over this times this is what we started with, okay? And so I'm just trying to make things a little easier here. And so now I have 1 over h times f of x plus h minus f of x. This is the exact same thing. So now what this is going to be is, it's going to be 1 over h times, well, what is f of x plus h? It's negative 6 over this plus 9, but I got to put an x plus h in here. So I got negative 6 over x plus h plus 9, okay? And then minus, minus negative 6 over x plus 9. Now, I don't need these parentheses around x plus h. I just have x plus h plus 9. We're just going to call that one denominator. And over here I have x plus 9. And I forget to put in the large parenthesis. Okay? And so now we've plugged in x plus h into f of x, and then this is just f of x, and we're subtracting. Okay? Now, in order to subtract these or combine them, I need a common denominator. The way I'm going to have a common denominator is I'm going to multiply this side over here by x plus 9 top and bottom. And over here I'm going to multiply by x plus h plus 9 top and bottom. Okay? And this is what it's going to look like. It's going to become equals, I've got my 1 over h. That hasn't changed yet. And then here I'm going to have negative 6 times x plus 9 over x plus h plus 9 times x plus 9. All I did, this is a parenthesis, all I did was multiply the top and the bottom by x plus 9, which is this denominator over here, minus negative 6. Now I'm going to multiply this one by x plus h plus 9. So x plus h plus 9 over x plus h plus 9 times x plus 9. Because I multiply the top and the bottom by x plus h plus 9. Okay? We're doing that so we'll have a common denominator. Now we do. We have this and this, same denominator. Okay? And so now what we can do is, because we have a common denominator, we can now distribute this negative 6 here. We can distribute this negative 6 here, and then we can combine them with the minus. So let's do a couple more steps here. I think I'm going to go over this way a little bit. 1 over h, it's an h. So negative 6 times x is negative 6x, and negative 6 times 9 is negative 54. So I'm going to have negative 6x minus 54 over x plus h plus 9 times x plus 9 minus. Here I'm going to do negative 6 times x, negative 6x, negative 6h, and negative 54. So I'll have negative 6x, negative 6h, minus 54. Okay? I'm going to put that in parentheses because I'm subtracting it. And so I want to be careful. I'm subtracting this, and subtracting this. All over x plus h plus 9 times x plus 9. Okay? There we go. Now we're going to clean it up a lot. It's going to get cleaned up a lot. This is now going to be equal to 1 over h times, we can turn this into one fraction because we now have a common denominator. Okay? And so the common denominator is going to be x plus h plus 9 times x plus 9. There we go. And now we're going to do negative 6x minus 54, there it is. Now we're going to do minus negative 6x. Well, minus negative 6x is plus 6x. So plus 6x minus negative 6h. That's plus 6h. Plus 6h. And then minus negative 54 is plus 54. So plus 54. Now if you need to slow this down or re-watch parts of this, you should go ahead and do that. But here's where it's going to get really, really easy. We now have a negative 6x and a positive 6x. They're going to cancel each other out. We have a negative 54 and we have a positive 54. They're going to cancel each other out too. And all we have left in the numerator is 6h. So we have 1 over h times 6h over x plus h plus 9 times x plus 9. Okay? And now I can now multiply my 1 over h by this thing. And here's what it's going to become. 1 times 6h is just 6h. In the denominator, I have h times x plus h plus 9 plus x plus 9. I'm not going to combine them. I'm just going to leave them all separate. X plus h plus 9 and x plus 9. And now look, the h's cancel, just like in that last example we did. The h's both cancel. And our final answer is 6 over x plus h plus 9 times x plus 9. Now I want you to notice the connection here, that we started with negative 6 up here, and now we have a positive 6 down here. We started with an x plus 9 here, and we have an x plus 9 here. And then next to it, multiplied by it, we have an x plus h plus 9. And so this creates a sort of pattern. It's a really great pattern, where if we had another one that looked very similar to this, the answer would also look similar to this. So like, let's say that I had f of x is equal to positive 9 over x plus 5. Well, then the difference quotient, f of x plus h minus f of x over h, would be equal to, well, here I have negative 6, here I have positive 6. So I got to reverse the number in the numerator, so it's going to become negative 9 over, and then here's an x plus 9, and I have an x plus 9 in the denominator, x plus 9, but this time it's x plus 5, so I'll put x plus 5. And then I also have an x plus h plus 9, so I'll have an x plus h plus 5. And so you can see I was able to do that without doing all this stuff in the middle, because there are shortcuts for doing difference quotients. And so all I'm doing here is just sort of a shortcut in doing a difference quotient, and I'm hoping that that helps you. And I know this is a little crazy, but it's really convenient that most of the stuff cancels out. And I really hope that you're able to, if you have to watch this a couple times, you may have to just wrap your mind around it.